Today we're going to talk about how to perform analysis on surfaces that may be skewed relative to the global coordinate system. Typically, when you do analysis in ASAP, you do the analysis by defining a window command, which is perpendicular to one of the global axes, and then you give it a size. From this, ASAP will then store the data. But let's take a look at a simple system that we have here, which consists of 3 surfaces, planar surfaces, 2 of which are reflectors, and those reflecting surfaces are at outside the standard coordinate axes. They are rotated a little bit. The system is basically set up as a retroreflector, almost. And let me run the file, and we'll see first off a quick picture. So here is our first surface, which is oriented within our global coordinate system. It is perpendicular to the z-axis. But then we have these 2 reflecting surfaces that are skewed in that coordinate system. And what's happening within the ray trace is the light is passing through this first surface, reflecting again, coming back and reflecting, and then passing through. Because we have a slight additional skew on this upper reflector, we don't quite have a retroreflecting system, but that's what the goal is, to show you how the light reflects back through the system. And if we look at it in 3 dimensions, you can see a little bit easier what we're talking about. So here's simply a transmissive surface in the standard coordinate system, and then the 2 reflectors. Now, maybe what we're interested in is seeing what the energy distributions look like at some of these surfaces. And we can do that by setting up ray traces that only go from one surface to another. So, for example, I can start at the source and just trace the rays to the first surface, and then do analysis on that surface. And then we're also going to look at some analysis on the third surface. And we'll take a look at what that looks like. And these are simply some spot diagrams for a randomized set of rays. And you can see on the surface that is perpendicular to the z-axis, we see a nice square distribution of rays, as what we would expect from the emitting source that we're using. And similarly, the false color plot shows the same type of data. However, if we look at plane 3, which was the skewed surface, what we see is a ray distribution that looks like this. And in the false color plot, we see the same information. Now, as you saw previously in the figure, this surface is square, and our light distribution is square. So we would typically expect a square spot pattern or radiance pattern on that surface. The problem is when we defined a standard window, it was perpendicular to the z-axis. So in this case, if we click right here, we're talking about a plane that is oriented in this fashion. Unfortunately, our mirror is positioned like this, and if you'll notice, if we look at this in the global coordinate system in the XY plane, you see exactly the ray pattern that we saw on the spot distribution plot. So in other words, this data is correct, but it's in the wrong orientation. What we would like to be able to do is adjust our orientation so we actually see what the spot's position or what the irradiance looks like on the surface itself. And that's actually quite easy to do with an ASAP. It just requires a different command. And the particular command we're going to use is what's called the axis command. The axis command, in particular with the local modifier, allows you to change the orientation axis for your next calculation, in this case, the spot's position command. What our axis local, in this case plane 1, is saying, for the spot's position command, define a window that is defined based on the local coordinate axis of the defined piece of geometry, plane 1. So now we're going to define our analysis window in the coordinate system of plane 1. Now, since plane 1 is indeed oriented in the global coordinate system, this will make no difference. But for plane 2 and plane 3, which are skewed to that coordinate system, what we're going to also do is simultaneously skew our analysis window. So we're going to run through a calculation, and we'll look at the spot's position at each of those surfaces. And in this particular case, we're saying what the relative orientation and scale is similar to a window YX window 1.5 command if we were in a standard coordinate system. And then what we'll do is take a look at all of these on top of the three-dimensional view. And those pauses aren't necessary anymore, so I will just run this one more time. Okay, so now we see that indeed we have properly oriented on the surfaces the spot distribution. And to look at it in 3 dimensions, we'll just take a look here. And what we've done is taken the view of the geometry, and on top of that view of the geometry, we can overlay the individual spot diagrams. And as we rotate around, we can see the spot distributions or radiance patterns on each of the surfaces. And let me hide the rays because it makes it a little bit easier to see. What we've tried to show you today was how to set up your analysis in ASAP so that you can properly analyze the data on surfaces that are skewed relative to the coordinate system. All that is required is to simply tell ASAP which axis you wish to use as the reference point for the analysis.